March 7, 1945, 0900 hours. Recklen Test Center, Germany, 50 miles north of Berlin. Hauptmann Werner Voss stood beside the runway and listened to a sound no German pilot expected to hear this close to home. The low, smooth growl of a Packard-built Merlin engine. A silver fighter rolled toward the threshold, its silhouette unmistakable. Long nose, bubble canopy, laminar flow wings. By every visual cue, it was an American P-51 Mustang, except for the black crosses on its wings and the swastika painted on its tail. The aircraft should not have existed here, yet it was about to take off. The Mustang had arrived at Recklen 3 days earlier, flown in short hops from a forward recovery field near the Dutch border. German ground crews patched bullet holes, replaced damaged panels, flushed fuel lines, and filled its tanks with aviation gasoline that Germany could no longer afford to waste. Now, the Luftwaffe's most experienced test pilots would finally answer a question the German High Command had avoided for nearly 2 years. What were American fighter pilots really flying over the Reich? The aircraft carried U.S. serial number 43 to 24,687. Its previous pilot, 2nd Lieutenant Robert Chandler, 51st Fighter Group, had force-landed in a wheat field after flak damage near Osnabrück. Chandler destroyed what he could before Wehrmacht troops arrived, but the airframe survived largely intact. Recovery teams moved quickly. Within hours, the Mustang was on a flatbed truck heading east, toward Recklen, the Luftwaffe's primary flight test facility. Werner Voss was assigned as lead evaluator. He had flown Bf-109s since the Battle of Britain. Transitioned to the FW-190 in 1942. Briefly evaluated the Me-262 jet the previous autumn. His logbook showed over 3,200 flight hours, most of them in combat. He believed he understood aircraft. He believed he understood American fighters. He was about to discover he was wrong. German assumptions. By 1945, Luftwaffe planners believed the mathematics of aerial warfare were settled. German fighters climbed faster, turned tighter, carried heavier armament. The Bf-109K could reach 36,000 feet. The FW-190D rolled faster than any Allied fighter. On paper, German aircraft held the advantage in a dogfight. Yet the war was not being fought on paper. American fighters were appearing over Berlin, Dresden, Munich, targets German planners insisted were beyond single-engine escort range. Bomber formations that should have been vulnerable during their return legs remained protected all the way back to the English Channel. Something didn't add up. Reichsmarschall Hermann Göring had repeatedly declared long-range escort fighters impossible. The laws of aerodynamics, he insisted, forbade any single-engine aircraft from carrying enough fuel to escort bombers deep into Germany while remaining combat-capable. Either the aircraft would be too heavy to fight, or it would lack the range. There was no third option. The Americans apparently hadn't accepted that conclusion. First flight. Voss climbed into the Mustang's cockpit at 0915. The seating position felt unfamiliar. German fighters placed the pilot lower and farther back. The Mustang sat him higher, with visibility that bordered on unsettling. In a Bf-109, armor plate sat directly behind your head. In the Mustang, plexiglass surrounded you. You could see everything. You were protected by almost nothing. The instrument panel was laid out with American logic. Clean. Uncluttered. Every gauge labeled in English. Airspeed in miles per hour, altitude in feet, fuel measured in gallons. The fuel system immediately caught his attention. German fighters carried a single main tank, sometimes a small reserve. The Mustang had 6. 2 wing tanks, 2 fuselage tanks, 2 external drop tanks. Voss did the math. Internal fuel, 269 gallons. External tanks, 110 gallons each. Total fuel load, nearly 500 gallons. His Bf-109 carried 88. By every rule of German fighter doctrine, that much fuel should have made the aircraft sluggish, overweight, unflyable in combat. Voss started the engine. The Merlin caught instantly, settling into a smooth, confident rumble. Less vibration than German inline engines, less mechanical harshness. Throttle forward. Acceleration immediate. Tail up early. At 90 miles per hour, the Mustang lifted off. Climb rate exceeded his expectations. At 15,000 feet, he leveled out and began systematic handling checks. Roll response crisp. Pitch smooth and predictable. Stall warning gentle, forgiving, far more forgiving than German fighters. Then he checked the fuel gauges again. After takeoff and climb, he had burned less than 30 gallons. More than 400 remained. The impossible becomes real. Voskita's radio. Recklin control, beginning extended range evaluation. He pointed the Mustang west. At 25,000 feet, he reduced power to cruise settings, what Allied pilots called maximum range power. The Merlin settled into an economical rhythm, burning roughly 45 gallons per hour. The implications were unavoidable. At cruise, the Mustang could fly for over 8 hours. Not just reach Berlin, but patrol over it. Fight. Then return home. Voss had flown bomber interception missions where he had 15 minutes over the target before fuel forced disengagement. American pilots could loiter for an hour and choose when to fight. He pushed the Mustang harder. Combat maneuvers with full internal tanks. He expected heavy controls, degraded response. It never came. The fuel tank placement distributed weight along the aircraft's centerline. Handling remained consistent. As fuel burned down, performance improved. After 90 minutes, Voss had flown more than 300 miles from Rechlin. His fuel gauges still showed over half capacity. No German single-engine fighter could do this. Not the 109. Not the 190. Not any prototype still on the drawing board. A realization. Voss turned back toward Rechlin. For 2 years, Luftwaffe intelligence had dismissed American claims about Mustang range as propaganda. The numbers had seemed impossible. Now he understood something worse. German assumptions about what was possible were wrong. When he landed, Oberst Peterson met him on the tarmac. Your assessment? Voss shut down the engine and sat in silence for several seconds. Everything we've been told is incorrect, he said finally. This aircraft can go anywhere, fight anywhere, and return home. We cannot. Peterson nodded. I reached the same conclusion. The Mustang had not simply extended American fighter range. It had invalidated the Luftwaffe's entire defensive strategy. And Germany had no answer. The Mustang did not win its reputation in a single flight. It earned it in numbers. Over the next 3 days at Rechlin, 6 Luftwaffe test pilots flew the captured P-51 for a combined 37 hours. Each sortie followed the same pattern: range evaluation, fuel consumption measurement, then aggressive handling tests meant to expose weaknesses. None appeared. What emerged instead was something far more dangerous than a superior dogfighter. The Mustang was a strategic aircraft disguised as a tactical one, the wing that changed the equation. During the third evaluation briefing, a pilot recently transferred from the Eastern Front raised a hand. The aerodynamic efficiency exceeds anything we've achieved, he said. That laminar flow wing reduces drag far beyond our estimates. Combined with the Merlin's fuel efficiency, it explains performance we believed impossible. The laminar flow wing was one of the Mustang's least visible and most decisive advantages. Conventional fighter wings experienced turbulent airflow beyond roughly 30% of their chord. Turbulence created drag. Drag consumed fuel. Fuel limited range. North American Aviation's engineers designed an airfoil that maintained smooth airflow across nearly 60% of the wing surface. Less turbulence meant less drag. Less drag meant lower fuel burn. Lower fuel burn meant range. German engineers understood laminar flow theory. They had experimented with similar designs. The problem was manufacturing. Even minor surface imperfections, raised rivets, uneven panel joints, destroyed laminar flow. American factories solved that problem. Flush riveting. Precision tooling. Assembly tolerance is tight enough to make laminar flow work in practice, not just in wind tunnels. The Mustang's wing was not just an aerodynamic innovation. It was a manufacturing achievement. A pattern becomes clear. Voss spent evenings reviewing combat reports from the previous 18 months. Once you knew what to look for, the pattern was unmistakable. Before the Mustang appeared in large numbers, German fighters inflicted catastrophic losses on unescorted bombers. In October 1943, the 8th Air Force lost more than 25% of its aircraft on missions to Schweinfurt and Regensburg. Deep penetration daylight raids were temporarily suspended. Then, in early 1944, Mustangs began appearing in force. By March, they were escorting bombers all the way to Berlin. German losses rose sharply, not because the Mustang was unbeatable in a turning fight, but because American pilots controlled the tempo of combat. Fuel changed everything. German fighters, limited by range, had time for a single attack. If intercepted by escorts, they were forced to disengage quickly or risk running dry. Mustang pilots could patrol, re-engage, climb back to altitude, pursue fleeing aircraft all the way to their airfields. The attrition equation flipped. One German ace summarized it bluntly during the Reckland discussions. "We are fighting with our hands tied. We must attack immediately. They can wait." Another officer added, "War isn't fair. But this goes beyond normal imbalance. They decide when and where combat happens. We can only react." Berlin receives the report. The Reckland evaluation reached Luftwaffe headquarters on March 10, 1945. General Oberst Hans-Jürgen Stumpf read the summary in silence. "So this aircraft can escort bombers to any target in Germany," he said finally. "Fight our interceptors and return home?" "Yes," his intelligence chief replied. "We verified the data. The reports we dismissed as exaggeration were accurate." "Why?" Stumpf asked. "Were we not developing something similar?" The room hesitated. "We were told it wasn't possible," came the answer. "That long-range escort would destroy fighter performance. That American claims were propaganda." Stumpf's expression hardened. The Americans apparently did not accept that conclusion. The irony was brutal. Germany had the engines, the aerodynamics, the engineering talent. What it lacked was belief and time. Long-range escort fighters had never been prioritized. Luftwaffe doctrine focused on defending airspace and supporting ground forces. By the time leadership recognized the strategic necessity of escort fighters, Germany no longer had the industrial capacity to build them. Even if development had begun in 1943, operational aircraft would not arrive until mid-1945. The war would be over before then. Attrition without recovery. Combat loss reports painted a grim picture. In January 1945, the Luftwaffe lost over 500 fighters. In February, more than 600. March was trending worse. Experienced pilots were dying faster than replacements could be trained. In early 1944, Germany fielded roughly 2,000 veteran fighter pilots. By March 1945, fewer than 500 remained combat-capable. New pilots entered combat with 50 flight hours, facing Americans with 300 or more. The Mustang magnified this imbalance. Veterans might survive by skill and caution. New pilots rarely lasted more than a few sorties. The aircraft's range didn't just provide strategic reach, it provided tactical persistence. Mistakes could be punished relentlessly. The final test. On March 12, Voss returned to the Mustang for dedicated combat evaluation. At 30,000 feet, he pushed the aircraft into regimes where German fighters struggled. In a high-speed dive, the Mustang remained stable past 400 miles per hour, free of the compressibility issues that plagued thinner-wing designs. In sustained turns, it held 6 gs for over a minute without bleeding energy catastrophically. In a zoom climb from level flight, it gained more than 5,000 feet before stalling. But what impressed Voss most was not raw performance. It was balance. German fighters excelled in specific areas. The Bf-109 climbed superbly but rolled poorly. The FW-190 rolled beautifully but sacrificed climb. The Mustang did everything well, and it could do it 700 miles from home. After landing, Voss added a final note to his report. "This aircraft represents not merely a technical achievement, but a philosophical one." American designers believed the escort fighter problem could be solved and committed resources accordingly. "We declared it impossible and did not try. That failure of imagination is costing us the war." The report was filed. Copies circulated. Pilots read it quietly in ready rooms. Mechanics discussed it while servicing aircraft. Everyone understood what it meant. Germany had no answer. By March 1945, Germany still had brilliant engineers. What it no longer had was the ability to turn knowledge into results. The difference was not intelligence. It was process. American engineers began with a requirement and asked how to meet it. German engineering often began with assumptions about what could not be done. One philosophy, search for solutions. The other accepted limits. Over 4 years, that difference compounded. Industry as a weapon. By March 1945, the United States had produced more than 15,000 P-51 Mustangs, with output peaking above 500 aircraft per month. North American Aviation's Inglewood plant operated around the clock, assembling Mustangs in under 5 hours of final assembly time. Components arrived from hundreds of subcontractors, designed to fit without adjustment. Interchangeability was expected, not hoped for. Germany never approached this scale. In early 1945, total German fighter production across all types barely exceeded 500 aircraft per month. Bombing, fuel shortages, and the loss of skilled labor crippled output. But even without bombing, Germany could not have matched American production. The problem was not capacity alone. It was methodology. German aircraft were finely crafted machines, often requiring hand fitting by skilled workers. American aircraft were engineered for repetition, speed, and scale. Quantity beat refinement. The engine that explained everything. The Packard-built Merlin engine illustrated this perfectly. It was a licensed copy of the British Rolls-Royce Merlin, produced in a converted automobile factory in Detroit. Packard engineers redesigned it for American tools, tolerances, and mass production. Performance matched the original, but production was faster and cheaper. Packard built over 55,000 Merlin engines, each requiring about 1,000 labor hours, producing more than 100 engines per day at peak output. Germany's Daimler-Benz DB605, a superb engine powering late-model Bf 109s, required over 2,000 labor hours per unit. Production never exceeded 500 engines per month. Germany built excellent engines. It simply could not build enough of them. The final evaluation. On March 15, 1945, Voss flew the captured Mustang one last time. Allied armies were closing in. Rechlin would soon fall. He climbed to 40,000 feet, where the Merlin's two-stage supercharger maintained power long after German engines faded. The aircraft remained stable, responsive, and confident. From that altitude, the war was visible below. To the west, American bomber streams moved deeper into Germany, escorted without interruption. To the east, Soviet forces advanced relentlessly. The outcome was no longer in doubt. The Mustang had not caused Germany's defeat, but it had accelerated it by making daylight bombing sustainable and stripping the Luftwaffe of control over its own airspace. Air superiority was no longer contested. It was owned. Voss landed and filed his final report. The P-51 demonstrates that the Americans understood modern aerial warfare better than we did. They built fighters that could go wherever bombers went. We did not. That failure was decisive. The lesson: the technical intelligence gathered at Rechlin came too late. Germany lacked the time, resources, and industry to apply it. But the lesson endured. In post-war memoirs, German pilots repeatedly cited the Mustang, not as a superior dogfighter, but as a symbol of miscalculation. American pilots had fuel for patience. German pilots did not. The Mustang violated no physical laws. Every part of it was understood by German engineers. What Germany lacked was belief. When Allied planners concluded that daylight bombing required long-range escort, American industry responded. The Mustang went from concept to dominance in 3 years. German programs, trapped by doctrine and bureaucracy, never caught up. The P-51 told a story larger than speed or range. One nation assumed problems could be solved. The other assumed some problems were impossible. In 1945, that difference decided the war in the air. The Mustang did not just escort bombers. It escorted inevitability.